Activity 1.1, review of powers and exponents. So what we just did in the getting started, we're going to take a deeper look on what the lineage is, that little tree that's happening, okay? So Jake wants to trace the lineage back 7 generations. How many sires, which is male parents, and how many dams, the female parents, are in the 7th generation? So we're going to be counting all the way till we get to the 7th, okay? An expression can be used to represent the product of a repeated multiplication is a power. A power has a base and an exponent. You know, I'm going to highlight that real quick because that's a wonderful statement right there. A base and an exponent. There's a little definition right there. A base is the power of the expression, and the exponent of the power is a number that is the times of the base used as a factor in the repeated multiplication. And there's a worked example. In this worked example, you can write a power as a product of writing out the repeated multiplication. So if I take 2 to the power 7, that is 2 7 times, and then we could put that in the calculator, or we can just put this little piece and we find out how many number of sires and dams our Rickson had. Okay, but let's break it down. Okay, here we go. So for generation number 1, we do want to say that this is 2, right? So we had 2 parents. Okay, next, after that, we double it. That's 4 grandparents. We double this. That gives me 8 great grandparents. We did that on the previous page. If we double this, we get 16 great great grandparents. Double this, we get 32. That gives me great 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 grandparents. If we double this, we should get 64. That gives me a bunch of great grandparents. And our last one, if we double this, you know I'm going to double check it just to make sure. You never know. 64 times 2 doubling. Sorry. 128 looks good to me for the great 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 grandparents. Okay. In these next 2 little sections, we do need the following page. Okay, we need to be able to answer. It says label the 4th column power, then write each generational total as a power. So I think I missed. Right, I was supposed to do this one. Sorry. Label the 3rd column expanded notation and the 4th column power. So let's do that real quick. Coming back. This is expanded notation. And this last one is power. So all we need to know is, what did I multiply here to get 2? Just itself. How would I write that as a power? That would be 2 to the 1st power, because there is only 1 2 giving me a 2 again. We can double check it. If I go to the calculator, I'm going to type in 2. The caret key, the up key, takes my exponent to the top. Hopefully you can see it. I'll zoom in a little bit. It went upwards. I can redo it again. 2, caret right here in the corner. 1 does give me 2. Next, how do I get 4 with 2? You're going to do 2 times 2. That means that there are 2 2's, making it 2 to the power of 2. And as you can see, the pattern's going to go on. And I want to go start with this side, and then we'll go this way. Check it out. So if this is 1, this is 2, that means there's going to be 2 to the power of 3, meaning there's 3 2's, because 2 times 2 is 4 times another 2 gives me 8. Very, very cool. Let's keep rocking and rolling. 2 to the power of 4. 2 times 2 times 2 times 2. That does give me 16. You can double check. Keep going. 2 to the 5th, 2 to the 6th, and 2 to the 7th. 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2, that's 5 times 2. Sorry for my ugly 2s. And the last one, 2 times 2 times 2 times 2 times 2 times 2, 2, 2, I think. 1, 2, 3, 4, 5, 6, 7. Beautiful. And that should give me that correct number. Okay. I do want to make sure we go over specifically what we highlighted right here. So let's use this example. Let me see what's wrong with my dogs. Playing upstairs, that's okay. So if I have 2 to the 7th, we are going to recognize, use a different color, that this 2 is my base. The base of a power is the expression that is going to be used. And then this 7 is my exponent, telling me that's how many 2's are going to be once I line it up. And as you can see, that's right there. Okay. Very cool stuff. Very, very interesting. Let me look at the back part. Let's see what we need to answer. We did number 2. We did number 3. Terrific. Looking at number 4. Let me zoom in. How many dogs are going to be in his 12th generation? Of course, we're going to do double check real quick. 2 to the 12th, which is 12 2's. We can definitely break that down. That's no problem for me. 2 times 2 times 2 times 2, that's 4 2's, times another 4 2's, times another 4 2's. That should be 12 2's. Of course, we're just showing the breakdown, but if I come to my calculator, we can press 2 to the up key, my caret key, 12. That gives me 4,096. That's a lot of great grandparents. And we could even say dogs, because it's just answering the question. Okay. Another thing to consider, how many total sires and dams are in the first 3 generations. That's just talking about generation 1, which is 2 to the first power, plus 2 to the second power, because that's generation 2, plus 2 to the third power. We can't say, oh, go to 2 to the third, because it's saying what are the total amount in all 3 generations, okay? So don't get confused with that. If you go back to the chart, I'll help you real quick. This is just 2. This is 4. This is 8. Double check with the table. 2 plus 4 plus 8. That gives me 14. Cool. Next video coming up. This was a great one. Please rewind it.